I gave you for a unit outline there last week. There were 7 types of problems. Some of them are very simple. Some of them are just sort of variations of other ones. I'm going to basically spend the next 3 days, each day sort of giving you sort of some sample problems and then giving you the remainder of the time to work. If I need to give you Friday as a work period, I will. Otherwise, we'll sort of go right into the lab. The labs are so good that they basically take the place of doing lots of problems. Kind of thing, okay? Plan for today is Tuesday, right? This is a 5-day week. Is next week a 5-day week?
Yeah.
I think so, right? Remember to say something. So plan for the projectiles test to be the end of next week. Okay? It's a short unit. Okay, so after this, you'll be able to solve problems where projectiles are launched off a cliff at an angle of 0 degrees. And oddly enough, that is not what this is it?
No.
In fact, one can argue that this could be the 8th type of problem. What's different about this from all the ones that you've seen? The 7th one had different heights, but
You're shooting up.
yeah, the launch height was higher than the landing area, right? So in something like this, it's the reverse. But really, it wouldn't be any different, kind of thing. Anyways, I just kind of thought that's kind of a neat little animation, so I threw it in there. Let's begin. And again, as always, take down as many notes as you need. Alrighty, so as I was saying yesterday, if there's one thing, if I had to sum up this entire unit in one nutshell statement, it would be that sentence there. The vertical and horizontal motions behave independently of each other. That is the number one thing you got to keep in mind. They do not mix. Well, they do mix, but they don't. Vertical does not have any effect on horizontal, and horizontal does not have any effect on vertical. So, despite having a horizontal velocity, VH, the projectile has the usual vertical acceleration of gravity, which of course is minus 9.8. And I'll let you get that down. Number one is the vertical and horizontal motions are independent. VH stays the same at all times. If there's a second statement that's important, that's it. Which is why it's number 2 on this list. VH stays the same at all times. I.e., the downward acting force of gravity does not affect the magnitude of the horizontal velocity. It remains constant throughout. Does that make sense? That is, of course, neglecting air resistance, right? If there is air resistance, then there's going to be a problem. And if I were to sum up one thing, if I said there's a third most important thing, it would be this. Use the vertical velocity VV in all calculations relating to height of rise, time of rise, anything that has to do with going up or down. You must use VV, and in fact, initial vertical velocity might be a better description. Okay? Since it is only the vertical component of velocity which causes movement in the vertical direction. Vertical handles all the vertical, horizontal handles all the horizontal. You must keep them separate until the very end when you put them together. Okay, so the question is, a bullet is fired from a gun and air resistance is negligible. The muzzle velocity is 120 meters per second. There's a word that you need to know, muzzle velocity. What do you think that means? Instant velocity at what instant? Right, at the initial, exactly. That's the speed that it leaves the muzzle, the launch speed. Okay? How far away will the bullet land if it takes 2 seconds to hit the ground? How far away horizontally will it take, or so how far away horizontally will it land if it takes 2 seconds to hit the ground? Do you need to write this down? Do you need to do any math on a calculator? I'm hoping you all realize the answer to that is no. Did I start it? No? Thought I did. Sort of gave away a bit of a big hint there, didn't I? How far away will it land if it takes 2 seconds to hit the ground? Do you? Jake. You might think it's a trick question. But the answer is B. Why is it B? V bar equals d over t. How fast is it going? 120 horizontally. Time is 2 seconds. Okay? Is the 2 seconds a vertical or is it a horizontal characteristic? Or was it both? Why do you say both? Okay? Well, it's the time that it takes for it to go up and down, so it's definitely a vertical, right? But it's also the time it actually travels horizontal. So I would agree it's sort of one of both, right? It's one of both. But the horizontal time is really dependent upon the vertical time, right? And then they're the same, but it's because it runs out of ground, really, isn't it, right? Okay. Okay, so now how about a different one? And some of this we went over yesterday. A rock is thrown off a cliff at an angle of 30 degrees. There's the guy. Hopefully there's nobody down below. I went to the Grand Canyon with a friend of mine, engineer dude, a bit of a science nerd. He starts throwing rocks off it. I'm like, you know there's people down there, right? Ooh. At a speed of 10 meters per second. At its peak, what is the vertical acceleration? I think we went through this yesterday. Answer is C. What is the vertical acceleration? The vertical acceleration always remains minus 9.8. You cannot turn gravity off. Okay? What are these things equivalent to? 10 sine 30, well that would be the vertical velocity, and this would be the horizontal velocity, wouldn't it? Right? Should I draw a little triangle there? 30 degrees, there's the velocity, that's the VV, which is 10 sine 30, and this is the VH here, which is 10 cos 30, right? Okay, so vertical acceleration. What's the, oh, I think, oh, I was just about to say it. Yeah, I knew it was coming up too, I almost said it. What is the horizontal acceleration? It doesn't speed up or slow down. Horizontal acceleration is 0. Have I asked you that question more than once in the last 2 or 3 days?
Yeah.
Yes. Any ideas on how many more times I'm going to ask it?
3 more.
Until I get 100% yes, I get it. So I don't know how many times. Okay, let's actually do the sample. I don't know what movie that's from. Oh, actually, you know what? I think I do. Anyone know? No, I don't think so. I think it's Thelma and Louise, actually. Based on the car, I think. Hey? That is not the Dukes of Hazzard's car.
They're like family vacation.
I don't know.
That they kill their grandmas. It's something. Pretty good.
I don't know. Anyways, I always think of this type of problem as the stuntman driving off a cliff type of problem. Okay, so let's do this one here. Do you want to write this down? Yeah, like it. Car with an initial horizontal velocity of 24 meters per second goes off a 45-meter high cliff. That's basically it, right? When the car is like right there, what are the forces acting on it, Peyton? Horizontal and vertical? Forces, not velocities. Caitlin? Don't know? There's only one. Gravity. There's only one, right? Why is it still moving forward? Because Newton said, objects in motion tend to stay in motion. So the horizontal part of the car just thinks, oh yeah, well, I'm in motion. I'm just going to, keep on going. Oh, what? See, there's nothing below me? Oh, well, what can I do? Objects in motion have to stay in motion. Tough luck. The vertical component says, hey, there's a force on me. I'm going to accelerate downward until I come to a fiery crash at the bottom of the ravine. We don't know how it's going to end. Okay, so find the time of fall. How tall is the cliff? 45 meters. Note, calculate the time of fall for an object that is dropped straight down. This is the same as the projectile. Does it matter that it's being projected horizontally at, is it 25? 25? Is it going to take any longer for it to fall if it's being projected horizontally? No, because rule number one of all these problems is what? The horizontal and the vertical are independent. It makes no difference that it's going horizontal. None whatsoever. So all I really need to do is figure out how long it takes for an object to fall 45 meters down. Now, would you use d is equal to 45 or would you use d is equal to minus 45? And before you answer, would you use acceleration of minus 9.8 or positive 9.8? I think we would all agree that it would be minus 9.8, wouldn't we? So do I use 45 or minus 45? Exactly, Dan. Except in the minus sense.
Why do you use
In this case, it wouldn't matter. I could use 45, but then I would have to use 9.8. All you're really doing then is you're designating down as positive, and as long as everything down is positive, it's going to be okay. Right? Is time going to have a direction? Is time a vector? No. So it's going to come out kind of in the wash positive anyways, kind of, or it should, hopefully, right? So in this case, it really, really, really doesn't matter. However, having said that, if you were to throw something up like that off a cliff, would it matter? Oh, yes, because now you have two directions, and so one of them must be positive and one must be negative, and you better make sure you get them right. And we sort of, as a rule, denote down as negative. So maybe we better just not deal with that, and let's just say down is negative. Shall we do that? Okay, so minus 45 and minus 9.8. Okay, so how do I find the time of fall? D equals VIT plus AT squared. Now before, did you guys, have you got any room left underneath this here? I guess you could do it right now. I'm going to go back, because I probably should have done this. What is my horizontal component and what is my vertical component initially? Well, the horizontal is, oh, it wasn't 25, it's 24. The horizontal is 24. What's the vertical? A big fat 0. Which one do I use right there in VI? Right you are, Chris. 0. Why? Because this whole question is about vertical. How long does it take to fall a distance of minus 45? So I am dealing with vertical stuff. Minus 45 is equal to 0 plus 1/2 of minus 9.8 t squared. Does it have to be negative? Only if the 45 is negative, right? Because watch the next step. When I solve for this, I'm going to have what? Minus 45 is equal to minus 4.9 t squared. T squared is equal to... And if I didn't have both negative, what would I get? I'd have to be taking a negative a square root, and we all know that that's highly irrational. Not even one smile from anyone.
Imaginary.
I think it's irrational too, isn't it?
Imaginary numbers are when you take the root of a negative.
Yeah, I know. Rats. science nerd joke fail. What would t equal to?
I still appreciate it.
Did you? You appreciated the attempt? I feel bad that I messed that up because I should know better. Let's just pretend that whole thing was imaginary. Anderson. Eh? Yeah, exactly. What is t here? It's going to be really close to 1, isn't it? What is it? 3.02? 45 divided by 5. Should be, oh, sorry, it should be close to 9, shouldn't it? Oh, I got to take the square root. Right. So 3 point something. Sorry. What is it? 3 point what? 3.02 seconds. Okay. Relatively easy, really, right? You know. Is it any different than if I just dropped it off a cliff like we did back in Unit 1, I guess? No, really it's not. Okay. But the question is, how far from the base of the cliff will the car land? Right? Because if they're going to put, like, you know, some kind of device to make the car blow up extra special, I guess they'd probably put it in the car. They wouldn't put it on the ground. But they want to know where it's going to land, right? They want to have their camera set in the right spot or something like that. I don't know. How far from the base of the cliff will the car land? I'll redraw. The whole thing takes 3.02 seconds. I want to know how far away. I'm looking for a distance. VIT plus a half AT squared again? Well, let's just write that down. Don't write it down just yet. Could I use that? Ah, Brandy says there's no acceleration. Horizontally, right? Good, you're absolutely right. There's no horizontal acceleration. But I guess you could say, well, that just means that it's 0, and what happens? That just sort of disappears, right? And basically what you've got here, oops, I missed, d equals VIT. Is that not really the same as that? Is that not the same? It is, isn't it? Right? So I don't care whether you use this or use that, you're still going to get 24 times 3.02. Uh, 72.06 meters. Is that right? Does that make sense that we could use this? And I don't know if it helps or not. I mean, maybe it does to sort of, you know, nail down the fact that there's no horizontal acceleration. Or you can do this and just say, well, yeah, it's a constant velocity, it's a constant 24, I'm just going to use this. I mean, this formula is really an extension of this one, really. How are you feeling about that? I'm looking for some kind of feedback. I got a little bit from some people, but there's almost always this question at the end. What is his, and I shouldn't say his, it's a little gender specific on me, what is the velocity impact? Here's where the horizontal and the vertical combine together. How come? Because it's asking you to do that. It's saying, what's the overall velocity? So you have to add the horizontal and vertical components together.
So would the vertical component, it wouldn't be 0 for all of it?
No, it would not. Excellent, Dallas. That was my next question. I was going to start with the easy one, though. You're thinking ahead. What is the horizontal component impact? 24. Remember, it doesn't change. Dallas is saying the vertical is not 0. How come? Because of acceleration due to gravity. Do we know the vertical component impact? No. Can we figure it out? Of course. And that's the first step. Right? What is the initial vertical component? 0. What is the acceleration due to gravity? Minus 9.8. What is the time? 3.02. Lucas still has my calculator.
It's been like 3 months.
Well, a week or two maybe. 29.6, we'll say. Is that my final answer? No, that's only one component, isn't it? Only one part of it. So how do I find good old V here? Yep. When you first learned Pythagoras, did you really understand how many times you were going to use it in your future? Or did you just think, I'm going to learn this and then forget about it in a week? Now, do I need to put a negative in that 29.6 in there? No, because we're just finding out a triangle now, right? It makes no difference. And if you do put a negative in your square, you're just going to get positive anyways, right? So. Is that now the end? It's a vector. Yeah. Opposite, 29.6, adjacent, 24. Oh, it must be in radians. (51 degrees). Now, what would you put for a sort of a description at the end there? Like, how would you describe that 51 degrees? Can you say like east, south 51? Does that make sense in this situation? Not really, is it? Right? What you would say is BTH. Anyone? The middle word is the. 3 words. Below the horizon. 51 degrees or below the horizontal. Yeah. Don't need what? No. You can't because it's not. There's no. This is technically down, and this is technically, well, I guess sideways, right? And we don't even know if it's to the right. We didn't even. I mean, we just drew it that way, right? So below the horizon, that's good. Always say below the horizon. What if it's above the horizon? You got to be careful with always. It's interesting that talking. First thing to do is find the time of fall. We did that with. Oh no, not that one. D equals DIT plus 1/2 AT squared. And I'm going to click on here to get that started because everyone wants to see it, of course. And it's 25 meters minus 25 minus 25. The initial vertical velocity is 0 plus 1/2 of minus 9.8 t squared. And you should get a t value of negative 25 divided by minus 4.9 is 5.01, and take the square root of that. I get 2.26. Yeah? Got that? Okay. And then how far from the base of the building? Actually, do I need to do, the next step is really just what? V bar equals d over t, right? I think that's all the next step is. What was the horizontal velocity? 1.5. D over 2.26. 3.4 meters. Did you guys solve this wrong or something? Oh. Yeah. That's distance, right? Okay. How many marks would that be worth on a test, I think? Just 2, yeah. Just 2. It's pretty straightforward. Well, yeah. This is so 80s, you guys.
very far from where we are right now. That's when we started running over things with a